So a slight change in the agenda. One of the panelists is still on the road. So what we will do is we will swap. Manojit is here. So Manojit will go next, and then we will have the panel after that. I'll request Archana to introduce Manojit.
A very warm welcome, Manojit. Manojit is a researcher in Microsoft Research Lab in India since 2007. His research spans areas of artificial intelligence, cognitive science, linguistic. In particular, Manojit has been working on technologies for low research language, code switching, computational sociolinguistic, and conversational artificial intelligence. He has more than 100 publications in international conferences and refereed journals. Manojit is also an adjunct faculty at International Institute of Technology, Hyderabad, and Ashoka University. He also organizes the Panini Linguistic Olympiad for high school children and is founding chair of the Asia Pacific Linguistic Olympiad. Manojit holds a BTech and PhD from IIT Kharagpur in computer science and engineering. A very, very warm welcome to you, Manojit. Stage is all yours.
Okay, thank you. Am I audible? Yeah. Thank you, the organizers and IEEE for the invitation. I'm quite excited to be here. In fact, I was very excited to hear that there is a whole day on NLP happening in Bangalore, where we have been working on NLP for last, I have been here particularly for last 13 years, and the group has been there for 15 years. So it's a lot of, pleasure with which I talk here about the work that we are doing. And I'm very excited to share that with you. And thanks also to the last speaker, Debashish, for talking about the landscape of NLP in a very nice way. So it's a nice segue to the talk or the thing that I'm going to talk about, which is a little more specific and in some senses more difficult problem. Now, Debashish mentioned the failure that chatbot had while handling his query. In fact, there is a very interesting report from McKinsey, which was published in 2017, I think. They had done this study with experts on which areas of AI will take the maximum amount of time to get sorted out. So various things like vision, perceptual, motor activities, everything, right? And turns out creativity is the hardest. Creativity and social intelligence are the hardest. But then the next in row is natural language understanding. And the prediction is human level or human parity in natural language understanding will happen somewhere around 2050. Now, I'm not saying these numbers are very interesting. I mean, most of the time such predictions are wrong. We know, I mean, if you look at the history. But the point is that NLP is truly, truly hard. And what I'm going to talk about is one of the more difficult problems in NLP. So what the problem is in this slide. So there are 5 tweets taken from different parts of the world. I'm not sure if from the back you can read it, but I can't read it out for you because I don't read these languages, speak these languages. But people who can see it, can you tell me what's common to these tweets? They are all written in Latin script, yes, but they are not English. But something more common, more interesting. So all the tweets have more than one languages. So the first one there, it's Kibirsa Geldigim Ich Mochte, whatever, is Turkish and German. And that's from somewhere in Germany. And if you see this one, this is very interesting, from Southern Africa. Anybody can guess what languages are mixed here? Not Swahili, it's Southern Africa. Northern Africa. Swahili is more Southern Africa. One you should be able to read, many of you. French. So French is one of the language. The other is Arabic. So this kind of phenomenon is called code mixing or code switching. Code here refers to a language. So you're mixing more than one code or switching between codes. And this is actually an extremely common phenomenon across the world. And I don't have to talk too much about motivating for code mixing because we Indians do it all the time, right? We even have words like Hinglish. which is essentially, Hindi and English mixed. But I don't think anybody in India speaks a single language. You can't. I mean, think of day-to-day activities. If I ask you, you have to speak the whole day only using a particular language. You can't use any words from the other language, how hard it will be. So it's very natural to us. So we have been working on a project called Project Melange. Melange means mixing in French. So, and it's about processing code mixed languages. So we have been working on this for almost 7 years now. So I'm going to talk about what we have been doing at a very high level, because I mean, if I go deep, then I will be able to cover only a little bit, one of the problems maybe. But I'm here, so if you have deeper questions, we can always talk about those. So where code mixing happens is in multilingual societies. It's very important to understand that multilingual societies are places where almost all members of the society speak the same set of languages, and that's more than one, so multiple languages. So one person may speak English, French, learned French in school, another person speaks German and English and some other language, but that's not a multilingual society. Because individually you are multilingual maybe, but it's not a society level multilingualism. Societal multilingualism happens like say in Bangalore. Almost everybody would speak English, and I mean everybody in this room, let's say, not in entire Bangalore, but will speak English and maybe Hindi, a lot of you, Kannada, a lot of you. So naturally in any conversation we'll be mixing those languages. So several interesting things happens. So one is language preference. Nobody tells you when to use Kannada, when to use English, when to use Hindi, right? You just naturally know. There is a social rule behind it. Linguists, or more specifically sociolinguists, study these rules, but they evolve over time, and there is a set social norm for that. So this is called language preference, which language to use when. Then there is even something more interesting. It's called linguistic accommodation. In fact, last part of my talk will be only on linguistic accommodation, which is something like this. So imagine you are talking to somebody in English, and you are meeting a person for the first time, and at some point you realize that you share a common Indian language, let's say Kannada, and you switch to Kannada and start speaking in Kannada, but that person, even though claims understands, speaks Kannada, never responds back to you in Kannada. What would you feel about that person? You would think maybe the person is arrogant, a little rude, or something like that, right? So essentially people use language as a cue, or any kind of linguistic style, in this case we are talking of language, to exert or give you a cue about the social distance the person is having with you. So moving to an informal conversation using your local languages is a way of showing warmth, and not doing so is a way of showing distance. So this in linguistics is called accommodation. So you are not accommodating the language choice of the other person, so essentially you are rude. And of course, we already talked of language mixing, which happens all the time in India and actually all over the world. So that's some of the interesting problems in multilingual society. And unfortunately, like all the things Debashish talked about would very, very badly fail when people start mixing languages to our, digital assistants like Cortana. Cortana, aaj Bangalore ka weather kaisa hai? So if it was a Hindi Cortana, it will fail. If it was an English Cortana, it will still fail. So no matter which language you build, it will fail. We see this in speech-to-speech translation because people speak multiple languages. So when Microsoft released the Skype translator, speech-to-speech, the first version was in English-Spanish, and it badly failed because what people realized is when you know that the other person at the other end is talking Spanish, even if you don't know Spanish, the few words of Spanish you know, you will try to use it, right? I mean, when you go to Spain, you would say hola, hola, si, a few words you will use. So it's the same thing happening here, and the system failed. And of course, social media, if you want to do any kind of analytics, mixing, I will show you on numbers like how prevalent it is, but mixing is very, very common. So all the technologies fail. So we thought some time back that this is a very interesting problem, and at that time nobody in the world was working on this problem. So we thought, okay, let's see how, as a researcher, like we are supposed to think, let's say 10 years, 20 years ahead of time. So even though NLP doesn't work well, but when it will work well in a single language, these kind of problems will become more relevant. So let's try to solve this problem. And when I mean how to solve this problem, I mean two things. So one is if your text or speech is mixed language, how do you do translation? How do you do part of speech tagging? How do you do speech recognition? So all these different things. And then linguistically what it means is we are trying to understand code mixing from both structural and functional points. So structural is how are two languages getting structurally mixed? What is the grammar of it? What is the meaning? How the meaning is affected and so on. And functional means what is the use in, what is the function of mixing language? Why are we mixing language? In what context? And understanding the usage. So we are trying to understand it from both these levels. So in the rest of the talk, what I'm going to do is first I will talk about why do we care about mixing languages, then why is it a challenging problem, then an overview of how do we solve it, and towards the end, if we had solved it completely and had bots which could understand as well as generate code mixed languages, then what would happen? How would people react to it? So that's the last bit I'll talk about. So why do we care? In general, we do not have to motivate this hard to Indians, because they know that they do it all the time. Microsoft being an American company, fundamentally, you can imagine, in many non-multilingual countries, and English-speaking countries are the most non-multilingual. In fact, I will show you interesting statistics that even multilingual people don't speak their own languages when they go to US or UK. So that's a very interesting socio-linguistic phenomenon which linguists have also observed. So to tell them that this is important is hard. So when we started this project, some of the initial pushbacks that we got is, oh, this is a very peripheral thing, it happens only in India. Or something like, hey, mixing language is impure. Why are you encouraging people to mix language by supporting it through technology? You shouldn't do it. But of course, linguistically, both are wrong. So essentially, code mixing is much, much more prevalent than what you would expect, number one. And number two is, it's not a noise or nuisance. It is really a signal. It provides essential cues that otherwise you would not have in the text. So one big problem between speech and text is speech already has a lot of cue through what we call intonation, right? And those intonation cues are not there in text. I mean, there are some proxies like punctuation marks or emoticons, but nothing beyond it. But changing language might give a very important signal there. So let's show the first point first, that it's extremely common. So to prove that, first we looked at India, because we are in India and we know mixing happens. So we took public pages on Indian celebrities, Indian news channels, etc. from Facebook and looked at the sufficiently long threads, like more than 50 comments or so. So interestingly, all sufficiently long threads were multilingual. What it means is there would be at least 2 comments in 2 different languages. But that's not necessarily code mixing. It's like multiple people talking, commenting in different languages and so on. The second bit is even more interesting. Even in a single comment, right? How many of the single comments are mixed? So 17% of the single comments were also mixed, which is almost 1/5, right? A very, very high number. 1/6 of the comments were mixed. Well, does it happen only in India? Probably not. Linguists say that it happens everywhere, but measuring is hard. There is no solid data, right, for this. So we thought, let's go to Twitter, get tweets from various geographies, and try to measure code switching. But then, how do you measure? A tweet doesn't come up with a tag that, hey, I'm code switched. If you apply Twitter API, it will say only one language, right? Twitter API says it is either in Hindi or in English or in Spanish or in Chinese. It will never say it is in Chinese-English mixed. So we had to build our own tool. The challenge here is you have to build something called word-level language identifier. You don't want to identify the language of the tweet. For every word in the tweet, you want to identify what the language is. Now, if you have lots of data, again, it's a sequence labeling problem like part of speech tagging, named entity recognition. So training, then it would not have been a hard thing. But the problem is, again, you don't have data. And we are talking of lots of languages all around the world, right? So we need experts who understand those languages actually, and even monolingual people cannot do LID for code mixing. So you need to know both the languages which are mixed or sometimes multiple languages. So it's a very hard problem that way. So we solved it using an unsupervised technique where we use only monolingual data. I will give some hint on how we do it when we go to how do we solve it, that part of it. But what we find is really interesting. So we ran it on around 50 million tweets and from all over the world, and we found around 3.5% of all tweets were code mixed. And this is more like a conservative estimate. So probably the numbers will be around 5%, and which is actually pretty high. But in some geographies, it's higher. So this map shows various parts of the various cities from which we got the data. In each pie chart, there is a white wedge. There is a missing wedge, right? That's the amount of code mixing. So bigger the wedge, bigger is the amount of code mixing. So what you see here is, if you see Istanbul, it has the highest amount of code mixing. So something like 13 or 14%, if I remember correctly. Or similarly, Quebec City has a very high amount of code mixing happening, Mexico City, Spanish English happening, so on and so forth. The lowest amount of code mixing happens in the United States. Houston has 1.3% code mixing. And this is really surprising because Houston has a lot of Spanish and English bilinguals. In fact, United States is very multilingual. There are lots of, New York is extremely multilingual. So why it doesn't happen? So there are two reasons, I think. One is there is no societal level multilingualism. So even though individuals are multilingual, they do not always speak the same language together when they meet. The second is when people assert an identity through a tweet, right? Why would you use Hindi or Kannada in a tweet? It's a way of also asserting an identity that I'm a Kannadiga, I speak Hindi, kind of a thing. So in the US, probably people don't want to do this. They want to show that I am from the US. They don't want to, exert their non-US identity, that I am from Spain and now in the US, or I am from Mexico and now in the US, kind of a thing. So this actually spun off a lot of research in sociolinguistics, which we didn't do. People who study these things, they did. But nevertheless, I thought this was interesting. Now getting to the other bit, right? I mean, we may praise people in English, but गाली हम usually Hindi में ही देते हैं. And this is something very important. This is the bit where I was saying code mixing gives you a lot of signal. In this particular study that we did, right, what we tried doing is we took lots of tweets again from Indian language users, English Hindi bilinguals. We did sentiment analysis on it and tried testing various kinds of hypotheses which linguists have already mentioned about code mixing. Like, people express opinions in their mother tongue, emotion in their mother tongue, whereas, facts or technical things might be in a foreign language like English in this case. So all of them were not true for the tweet data, but the thing that we did find is there's a very strong preference for using Indian language, in this case Hindi, when they were expressing a negative sentiment. In fact, the chart on the left shows the fraction of tweets which uses swear words in Hindi versus swear words in English, and you see Hindi is always higher than English. On the other hand, the number of English tweets as such is much higher actually. So if I remember correctly, 70-30. 70% were in English and 30% were in Hindi. But still, if you look at the fractions, swearing happens a lot more in Indian languages. And there is an interesting nugget here, which is we also did a gender analysis. So tweets from women and men. So women in general swear way less than men on Twitter, which is not surprising. But what might be surprising is this data is generally true for men because the swearing data that comes is dominated by data from men. That's why the average shows this pattern. But for women, they switch more to English when they want to swear. So just the reverse pattern. And again, it's the emotional distance, right? I mean, English is supposed to be a more posh or sophisticated language or whatever, and swearing doesn't hit hard. But swearing in native language really hits hard. So, and what I'm talking about is nothing which we, hypothesized or found for the first time. Linguists talk about these things and they have done studies, but those are limited to like surveys of 100 people or data from 20 people or so, and as such. This was a study which we did on like 130 tweets, 1,000 tweets from like huge number, tens of thousands of users from Twitter. So the scale is what is interesting. And also that similar things happen on the social media.
Is that the real paper?
Sorry?
Is that the real paper?
Yeah, that's the real paper name. We have two papers on this. The swearing one has this title. So the thing is that inferences drawn on monolingual data only, let's say the majority language data, on social media analytics will be often wrong for multilingual societies. Because what will happen is, for instance, in this particular case, right, you are looking at a campaign and what is the overall trend, and you might find a very positive trend. You identify, looked at 70% of the tweets which were in English, analyzed and very positive. But you missed that 30% where actually all the negativity was, which were all in Indian languages. So therefore, it's also very important to look at all the languages, especially if you want to get the minority views and so on, when you are doing social media analytics for multilingual societies. Now, why is it challenging? There are two challenges broadly, and one, what I would say, a lost opportunity. So the first challenge is the problem of data. If we had a lot of data, we could actually train any system and it would work. But the problem is that for code mixing, nobody writes in code mixing. Code mixing is predominantly a spoken phenomenon. You won't have books written in code mix language. You won't have, in TV interviews, even on very formal channels like, news channels and all, you would see lots of code mixing happening. But it's spoken. When you go to the printed medium, the amount of code mixing is much less. So that's one problem. You won't get a lot of text data, which otherwise for monolingual, cases you would. Second is model explosion. So if you have n languages, and if you think of only pairwise, mixing, even then you have n square order n square possibilities, right? And it's not necessarily two mixing. So people in India itself have collected data sets of three-way mixing. It happens quite commonly. So English, Hindi, and the local language. So English, Hindi, Bengali, English, Hindi, Kannada. So three-way mixing. So then it would go to even higher number, right? So you don't want to make so many models for every other combination that happens. Third is the lost opportunity. You already have English models. You already have Hindi models. Can't you just use them? You already have data for these languages. Can't you just use them to make an English model instead of building from scratch? And this is very interesting because if you think of it from a cognitive perspective, a person who knows both the languages but have never heard anybody code mix would be able to code mix and would be able to decipher a code mix sentence without any difficulty, right? So we really don't need to learn code mixing separately. We can understand it as long as we understand both the languages well. We are fluent speakers of both the languages. So maybe we can train machines also to do so. So that's the third thing. Now, keeping all these things in mind, when we go to solve code mixing, we thought, okay, then the broad things we want to do is one, combine monolingual models, second, combine monolingual data, and third is, since we don't have data in code mixing, can we generate artificial data in some way and use artificial data for training? So broadly, what I will go through in next 4 slides is how people have tried to address code mixing at a very high level and what are the problems there, pros and cons. So one is, I mentioned in the beginning, right? If you had lots of data, you just throw a model on it and it will learn. And people have tried these kind of things. For instance, speech recognition. People have taken lots of code mixed speech. When I say lots of, actually the largest speech code mixed speech data has some 100 hours of data, which is by today's standard very, very minuscule. People talk of 10,000 hours of speech data. But still, you get a reasonable model, but it doesn't solve the problem of data. It doesn't solve the problem of lost opportunity and so on. This is a slightly better case, divide and conquer. What you do here, you take the input, let's say text, run a language ID on each word, word level language ID, divide it into fragments. So this is my L1 fragment, this is my L2 fragment, and pass the L1 fragments through the L1 model, L2 fragments through the L2 model, and then you get, combine the results to get the output. This might work, but it works only when these fragments are pretty large. So imagine you do not mix within a sentence, but you say one sentence in English, the next in Hindi, the next in English, the next in Hindi, then this method might work quite well. But if you are mixing within a same sentence English, Hindi, let's say one English word in an entire Hindi sentence, you strip off all the Hindi, take the English word and want to do a pause tagging for it, it will totally fail, right? You won't have any context. So that's the main problem, you lose context here. This is a better model which preserves the context. What it does is you take the code mixed input, let's say text again, pass it through both the models, the whole input. Don't separate the input. So both models will give some output and then combine it using some logic at the end. So a lot of speech recognition systems, for example, today use this technique. So use a Hindi speech recognizer, use a English speech recognizer, assume that the speech can be either English or Hindi or Hinglish. You pass through both and look at where the ASR system has higher confidence. So this is the combination logic, where it has higher confidence, which one has higher confidence and things like that. And you might use also a little bit of other kinds of things like language model of a code mix language and so on. And you can get a reasonable accuracy ASR which can keep switching between English and Hindi. But even here, the practical experiences, they work well when people do not switch too often within a particular sentence. So if your chunks are reasonably big, then this works fine. And some of the recent papers from Google, for instance, for their voice query search uses this kind of model. So the user doesn't have to say a priori that I'm now speaking in Bengali and then say the Bengali query. If you set that I speak Bengali, Hindi and English and speak whichever language, one of the three, it will recognize. And this is the kind of a structure that they use there. At least their papers say so. The one that I want to get into a little bit of detail is what I call zero-shot learning. Zero-shot because if you have unlabeled data, it's unsupervised. If you have labeled data, it is supervised. If you have no data, it is zero-shot, right? So here we are talking of a problem where we don't have any code switch data. I have only language 1 and language 2 data. I want to train a system with only these two data sets, so which are monolingual. And maybe a little bit of code switch data which somehow we gather, because a little bit is always required, I suppose. I mean, you can't assume totally zero data. I mean, I will show you models with total zero data also what they do, but they don't do very well. But with a little bit data, and little is like 5,000 words for a language model, let's say. And if you are aware of language modeling work, typically they use millions of words. And I'm talking of only 5,000. So with really little bit of data, but lots of monolingual data, you could train such a model. How do you do it? So the trick here is, can you use the monolingual data to artificially generate code switch data? And for that, there is a series of work by linguists and very interesting outcomes, theories. To motivate that, let's see this example. So here's a sentence. Teacher has issued a book from the library for the student in English. The first sentence is a code mixed one. Teacher ने library से student के लिए book issue की. Makes perfect sense, people who speak Hindi and English both, right? Teacher ने library से student के लिए book issue की. Alternate words are, I mean, this is the case I was talking about where all these techniques, earlier techniques would fail because you would lose context and all, right? Alternate words are from different languages. Now look at the next one. Teacher ने library from student के लिए book has issued. Does it make sense? Why not? So this is precisely the question linguists ask, that why the first one makes sense and the second one doesn't. And after a lot of work, theoretical work, linguists have come up with these wonderful theories of what happens when two languages are mixed, what happens to the grammar of the mixed language. And again, because of time, I won't get into the details of the grammar, but essentially, the things to be noted are there are many theories which talks of the constraints on the grammars when two languages are mixed. None of them explain all cases, but most of them explain a reasonable number of cases. They all start with a pair of parallel sentences. So they would, in this case, they would start with the Hindi equivalent of it. शिक्षक ने पुस्तकालय से छात्र के लिए किताब, whatever is the Hindi for issue की. And you take that, and that will be a parallel sentence, then build the parse trees, and then do some operations on the parse trees. And the theories say what operations are valid and what operations are not valid. That's how the theories differ. So we took some of these models, there are many, and implemented two of them. So once you give a parallel sentences, a pair of sentences, it will generate code mix versions. And there will be many, many code mix versions. For instance, in this sentence, you could also say, teacher has issued a book from the libraries Chhatra ke liye, or for the Chhatra kind of a thing, right? And it will also make sense. So there will be a combinatorial explosion, and let's see how bad the combinatorial explosion is. So actually, if you think of it, every word can have its English or Hindi equivalent. So in the worst case, it's 2 power n, where n is the number of words. But because of the constraints, it is not that bad, but still it grows exponentially. So here is a number of words in a sentence, and here is the number of code mix sentences that are generated through these systems. So that's one problem. A very large number of sentences are generated. The bigger issue is not all of them are natural. So what these sentences are is what I would call possible. They are grammatically possible, but they are not necessarily sentences which people will use all the time. So they are not necessarily natural. So we have to find out a way of sampling the natural sentences from there. By the way, I'm kind of telling you the story after we have done a lot of experiments. So it sounds like we already had thought about these things and did it this way, but actually not. We did the experiments first, and over the years we learned all these things. So that sampling is necessary is something which we learned after we did experiment with this entire data set, and so all the models actually performed much more poorly when we used synthetic data. So unless you sample it, it doesn't work well. So how do you sample naturally code mix sentences? Very hard problem. We are still working on it. It's an open issue. To motivate, right? Consider the word school. Now the school has many meanings in English. So one is an educational institute, a child goes to a school. One is a group, like a school of fish kind of thing, right? In a English sense, right? Which word of school do you think is more prevalent? The first meaning, right? When you say, if you want to say school of fish, you won't say Machliyon ka ek school. If you say Machliyon ka school, it will mean like, it's a animated world, like Nemo goes to a school kind of a thing. So that is the big challenge. So all the senses of words in the English and Hindi doesn't make sense in English. Only some of the senses are selectively more used. Similarly, noun phrases are much more often switched than, let's say, verb phrases. Verbs are switched much less often. So all these things are very hard to measure in general, and we don't even have, like, I'm talking in a very qualitative terms. Now when I have to quantify, I need data. From the data only I can quantify, and the data is the problem, right? I don't have data. So what we did, we used some proxies. The first proxy we used is very simple, number of switch points. So people usually don't switch on every other word. So if you look at real data, those 5, 6, 10,000 sentences that we had, there the number of switch points were of the order of like 1 to 2 per sentence, not more than that. So we could discard all examples where the switching was extremely, frequent. So we used sampling using switch points. There are certain things like code mixing index and all which linguists have defined. And again, you can measure how, integrated the mixing is. And using those also we could sample. Of course, syntactic and lexical signals, I said, is an open issue. We are still working on it right now. But it turns out in our experiment, this itself gave pretty good results. What we saw is if you are training a language model, let's say a deep learning model using RNN or BiLSTMs or something, then this is what works best. You first train with the synthetic code mix data with sampling, then train with the monolingual data, then train with the little bit of real code mix data. And that gives you a much better performance than if you had trained only on the real code mix data or only on the monolingual plus real code mix data. The paper has all the numbers and all. The second thing which is very important is this curriculum. You have to train exactly in the same order. If you change the order, like first you train with the real code mix data, then with monolingual, then with synthetic, then it will fail miserably. So it will work only when you train in this particular order, and in that case the synthetic data really makes a big jump in the accuracy. We applied the same theory for word embeddings. So word embeddings also need a lot of plain text corpus to train on. So we thought, okay, let's train on synthetic corpus and learn word embeddings for doing code mix tasks. Again, if you do the same thing and learn word embedding, it does much better than if you were to use other cross-lingual word embedding models like BiCCA or BiCV, and so on. So there are many such models. One thing I must say that all these models that we tested, these papers are 2018, so the models we tested them on are 2017 models, which by today's terminology are ancient. So 2018 came, Elmo, and then later towards the end of 2018 came BERT, and now the whole world is only talking of BERT. So we are redoing all the experiments with BERT to see if the results hold on BERT. Now, one interesting thing is in BERT kind of a framework, you can't even do CCA kind of insight, including conversational style and other things. I just mentioned syntactic and semantic, like this cool example or noun phrase, but there are also more context-related things which you might bring in to make it sound more natural. So I will move to the last part of the talk, which is, what if we solved all these things and we made chatbots which could just nicely, code mix, and people are interacting with them. So would people like it? So code mixing, as I said, is a very, very, it's a signal. Now, here is a conversation that's from this Bollywood movie Queen, where this guy, he's Kangana Ranaut's boyfriend, and he has returned from some, I think, UK or somewhere. And if you see the conversation, his name is Vijay. The blue part is English. Vijay uses a lot of English, whereas Rani doesn't. And this shows, and they break up, basically. This was the meeting where they broke up. And Vijay is showing, you are now different from me. So Vijay is using a lot more English to establish that. So there is a social distance there. So actually, the reason I use Bollywood to motivate this is all our initial experiments were on Bollywood data. That we collected scripts, and from there we analyzed how code switching is employed, and we tried to study this accommodation theory. So is it true that if you use Hindi, the chances of me responding in Hindi is higher than my baseline response rate in Hindi, and vice versa for English? So this is what linguists called accommodation. And what we found is the following. So with the human-human conversation data, which came mostly from movies, but also a little bit from Twitter conversations, we found that accommodation does happen, but only for what is called the marked language. So marked language is a language which is not frequently used in that conversation. So for instance, between two friends in Bollywood, both of them speaking Hindi, Hindi might be the unmarked language. Now, use of English will be marked language there, and the other party will typically accommodate for English, but not necessarily for Hindi. So this is what we found for human-human. So we thought, okay, let's make a bot which responds to the user in English and follows the same strategy. It accommodates following this kind of number, accommodation for the marked language. Of course, it's very hard to build a chatbot because we have to solve the entire pipeline, right, of understanding and generating code mixing. So we did a Wizard of Oz experiment. Actually, a human was chatting, but the user didn't know that it's a human who is chatting. And what the experiments show is users have a very strong preference for bots which can mix language. Oh, wonderful, this is a English bot, it also speaks English, how cool and all. That was the general tendency. But there was a group of users who were very, very critical of code mixing. They were saying this is supposed to be an English bot. This is supposed to be a digital assistant. Why does it need to mix? So I really don't like this bot. So what we thought is essentially we can't assume that our users will like it, right? So we have to somehow nudge the user to find whether the user likes it or not, and accordingly, mix or not mix, make a decision. So then we went on and made a bot which nudges. How it nudges? It will use just one word. Let's say all conversation in English and acha one Hindi word in the middle, something like that. And that triggers the user to use more Hindi, then this bot will use more Hindi. If the user doesn't, then the bot will go back and not use any more Hindi. It might nudge later after some time. So we just finished all those experiments with 100+ users, now analyzing the results. So very excited what we will see. So with that, let me thank you all. And this is not lie, this is Lie, just to make a point that language identification is very difficult. Okay, thank you.
So time for some questions.
Hi.
So I was just wondering that at this stage, have you managed to handle the spelling differences in linguistics? So the way I spell a certain word in my own language is different when my friend spells it. So have you handled that? Any heuristics?
Yeah, so absolutely we have to, I mean, that's a very good point actually. So all the social media data that we collect, especially for Indian languages, are what we call Romanized. So people don't usually type Indian languages in the native scripts. So Hindi is, I mean, only 15% of the Hindi is written in Devanagari. Remaining, I mean, out of 30, and remaining 15% were written in, English script. And in English script, there will be a huge amount of variation. And not only variation, I mean, it's like insane. So people will write H just to mean hai or ho or whatever, and you have to guess it from the context. So that itself is a hard problem, and we can solve it with a reasonable accuracy, at least for the purpose of language identification. But if you are to solve it in the sense of transliterating and understanding what word it is exactly in the context, so that also, I mean, given if you have a lot of data, you can do it. And one example is if you use these predictive keyboards like SwiftKey and all, you would see that if you type in, or even the Google Transliterate, so if you type in Indian language, it will give you options, and usually the first option is correct most of the time.
There was one more question
Jay.
there.
Yeah.
The number of switch points remain consistent in a predominantly English text versus predominantly Hindi?
So that's again a very good question. No. So what happens, what we have been seeing is when we look at I mean, in India, what happens is in the Hindi context, when Hindi is the unmarked language, people use a lot of English. The reverse is less true. If English was the unmarked language, like right now, I'm using very little Hindi, right? So when English is the major language, people don't switch much to Hindi. So therefore, the switching rate is much higher in Hindi major conversations than in English major conversations.
Last question.
There.
Thank you for an excellent talk.
Thank you.
Yesterday I got this problem actually. For my daughter's assignment, we are translating some Gandhiji's English quotes to Hindi.
Mm-hmm.
So as you said, some of the sentences are not making any sense only. Like when I'm translating. Even I've tried Microsoft Translator. So what is any other reliable source from where we can do?
So you tried to translate Gandhiji's quote from Hindi to English.
English to Hindi.
English to Hindi using various translators online, and they made no sense. Okay. So I am not surprised at all, firstly. Yes, that's why we are in business, exactly. And we will be in business till 2050, if we to believe the McKinsey report. But the main problem is, I mean, at least for the Microsoft thing I can speak. See, these machine translation systems depend on what data it was trained on. So for Microsoft machine translation system, the data it was trained on is mostly from industrial manuals. So the manuals come in multiple languages, right? So for English Hindi, we use the manuals and the parliamentary proceedings, which also come in both English and Hindi, and few books and all. Now, I would imagine that Gandhiji's, tenets will be more in the domain of philosophy, and the word usage and vocabulary will be very, very different. So naturally, that I'm not surprised that these systems would fail. If there is an alternative resource, unfortunately, no. In fact, tomorrow I am going to Chennai in a Tamil Internet Conference, which is an annual conference, and going to talk on the state of the art in Indian language NLP, especially Tamil. It's very, very pathetic. So Hindi is probably in a reasonable shape. Every other Indian language, like if you go to Kannada and all, there exist very little resources and almost nothing in public domain. So that's the tragedy, even though we claim that we have done big things, but that's for only English and Chinese or English and Spanish. Okay.
Thank you, Manojit.
Thank you.
For an excellent talk. I request Ima to give you a small memento of her thanks.
Thank you so much.
Thank you.